So let us start with the case of non-stationarity without unit root. Without unit root means there is no stochastic trend. So in this case, the series will be non-stationary only when it contains deterministic trend. So non-stationarity without unit root means the series exhibits only deterministic trend. So now let us start with the concept of deterministic trend. When the trend component is deterministic, then it is called deterministic trend. Very simple. How do we define trend? We have defined trend earlier just by looking at the changing value of y over time, that is delta yt. Delta yt is the trend. So if this trend is constant, that is no component of the random variables. So suppose delta yt is equal to beta. Beta is any constant. So what does it mean? In this case, the value of y will change over time at a constant rate. Okay. So this is actually the case of linear trend. Yt moves over time by following a linear path. So how we get it? So we have started with this. Trend is equal to beta. That is, trend is deterministic. Why we have started with this? Because we are considering the case of non-stationarity when there is no unit root. So there is no unit root means there is no stochastic trend, because we have already mentioned unit root is synonymous to stochastic trend. So when we consider the case without unit root, so in this case we have a trend which is purely deterministic. That's why we have started with this possibility. So just we can rewrite this expression simply in this form, because if you delta yt can be written in this way: yt minus 1 is equal to beta. If you take yt minus 1 in the right hand side, you have yt is equal to beta plus yt minus 1. Okay. So this is a linear difference equation, and you can solve the linear difference equation. By solving the linear difference equation, you can have this kind of expression. This is the general solution of the linear difference equation of this type. Okay. So we have started with this assumption: the change in y is equal to constant. Change in y is equal to constant means yt minus 1 is equal to constant beta. This expression is nothing but first order linear difference equation. First order linear difference equation. And you can solve the first order linear difference equation and you get the general solution like this: yt is equal to y naught plus beta into t. If you follow a simple process like the process of iteration, as we have followed already in our earlier cases, just by setting t is equal to 1, 2, 3, etc., you will get this expression. Okay. So here yt, that is the current value of y, is equal to its initial value. Y naught means the value of y at period 0 when we have started, plus beta into t. Beta is a constant. So if we multiply the time factor at a constant rate and add it to the initial value of y, you get the current value of y. And if you measure time along the horizontal axis and yt along the vertical axis, you will get a straight line with intercept y naught. So if beta greater than 0, beta is positive, you have upward rising straight line with intercept y naught. If beta is negative, you have negatively sloped straight line with intercept y naught. Okay. So when y changes at a constant rate, we can express this y in this format. This form is called yt, exhibiting deterministic linear time trend. Okay. So this is the theoretical behavior of yt. Actually, suppose yt follows this type of path, but not exactly on a straight line. So let me introduce some random deviation from this straight line. So to analyze the actual behavior of the time path of yt, suppose we specify yt in this way. Yt is equal to alpha plus beta into t plus epsilon t. Alpha is similar to y naught. So y naught, the initial value of y, now we denote it by alpha. This is the beta coefficient, and we simply add here epsilon t. And by the definition of epsilon t has mean value 0, variance constant, sigma square, covariance 0. So epsilon t is white noise, that is, it is a stationary or purely random. So if it is stationary, the deviation of yt from this line is simply epsilon t. And as epsilon t is white noise, this deviation will be a temporary phenomenon. Okay. Now, if we take the expectation of this, so this is simply like a linear regression equation where yt is the regressant, t is a regressor, epsilon t is a random component. If you take expectation on both sides, you have this kind of expression, and we call it a population regression function. So this population regression function is strictly a straight line. So you can compare this population regression function to our theoretical relation between y and t. So what is the difference between this and this? In this expression, we have linear relationship between actual value of y with time. But in the population regression function, we have linear relationship between the average value of y with time. So when we consider the population regression function, we can say the linear relationship between yt and t on average sense, not exactly in theoretical sense. Okay, so we can use this population regression function as a proxy for the theoretical relation, and this is the basics for econometric model. We have explained this part at the beginning of your class in SEM 2. Okay, so this is actually the mean value of y. So what is y? Y is this. How do we get it? By following the linear trend. How do we get the linear trend? By assuming deterministic trend. So if yt follows only deterministic trend, in this case its mean value is simply looks like this, alpha plus beta into t. So here yt following this path exhibits trend in its mean value because the mean value is time dependent. Expected value of yt is equal to alpha plus beta into t. That is y mean value of yt is time dependent. So there is a trend in the mean value. So as the mean value is time dependent, so yt defined in this way will be non-stationary. Okay. Now if we calculate the variance, yt is equal to this, you can calculate the variance uh, by applying the formula for variance in this way. You will get the variance of yt is equal to simply sigma square. That is, there is no time component in the variance. So the basic thing here we have to keep in mind, if we assume yt changes over time at a constant rate, or if yt follows this type of behavior, yt is equal to yt minus 1 plus beta, then the mean value of yt is time dependent linearly, but variance of yt is constant. As variance of yt is constant, there is no question of stochastic trend. But as the mean value of yt is time dependent, that is a question for deterministic trend. So in this case, if a yt is non-stationary without unit root, the series will be following linear trend in its mean value, but no trend in its variance. So what is the basic difference between non-stationarity with unit root and non-stationarity without unit root? In the case of non-stationarity with unit root, you have trend in the variance. But in the case of non-stationarity without unit root, you do not have trend in the variance. Okay? So non-stationarity with unit root synonymous to trend in variance or stochastic trend. Non-stationarity without unit root means no trend in variance, that is no stochastic trend. But in this case, we have a deterministic trend. Deterministic trend means trend in the mean value, that is, we have trend in the mean value in this expression. That's why yt will be non-stationary. Now, here yt is non-stationary, but if we consider or if we generate a new series by taking mean deviation, that is, you have yt as the original series, you have the mean value of yt like this mean value indicating a trend. So if you eliminate the trend component from the original, yt is the original series, you are eliminating the trend to get the new series zt. So zt is called the detrending series. Detrending means eliminating the trend. So after eliminating the trend component, trend means we are mentioning here, trend means the deterministic trend, no stochastic trend. So if we eliminate the deterministic trend from the series, we have a detrending series. And the detrending series zt, if you put the value of expected value of yt in this expression, you have only epsilon t. So after detrending, you have the random component epsilon t. So if you take the mean value of zt, it will be 0. You have calculate variance of zt, it will be sigma square. Therefore, the new series zt exhibits no trend either in mean or in variance. Okay, so what is the inner meaning of this process? The inner meaning is, if a series follows deterministic trend, or if a series exhibits trend at a constant rate in the mean value, the series will be non-stationary originally, but we can generate a stationary series just by detrending it. That is by eliminating the trend component from the original series. In our earlier case, that is, if a series contains unit root, in that case, the original series YT was non-stationary, and we can construct a stationary series by taking difference. Just remember the case of AR1, random walk model. In the random walk model, one unit root, YT has stochastic trend. So YT is non-stationary by nature. If you take the first difference of YT, you have a stationary series. And we can call this kind of process as different stationary process. So a non-stationary series with unit root, by taking difference, we can get a stationary series. How many times we need to difference to get a stationary series? That depends on the number of unit roots present in the series. If in a series there is one unit root, you need to take first difference to make it stationary. If a series contains two unit roots, you need to take second difference to make it stationary. If a series contains three unit roots, you need to make third difference to make it stationary. In the case of a series with d unit roots, as we have generalized in the case of ARP, you need to take dth order difference to make the series stationary. So we can construct a stationary series if it is originally non-stationary. But how to construct a stationary series depending on the nature of non-stationarity. If non-stationarity with unit root, we need to take the difference to make it stationary. If non-stationarity without unit root, we need to detrend to make it stationary. So in our second case, that is non-stationary without unit root, we can construct a stationary series just by detrending it. That's why this kind of behavior of the series is called TSP, that is trend stationary process. Trend stationary process means the series is originally non-stationary, but it becomes stationary after taking, just after detrending it, not taking a difference. Just by taking a difference, we have the case of DSP as in the case of with unit root. So in the case of with unit root, we have DSP. That means the series originally non-stationary, but it could be stationary by taking difference. In the case of non-stationarity without unit root, exhibiting only deterministic trend, the series originally non-stationary, but we can make it stationary by detrending it. And the process is called TSP. So non-stationarity may be of two types, DSP or TSP. So we are looking at the same thing in different way. Same thing means the notion of non-stationarity. When we started time series analysis, we have defined non-stationarity in terms of the behavior of the probability distribution. If the probability distribution changing over time, we call it non-stationary. If the probability distribution is time independent, we call it stationary. Then we redefine in terms of its moments in this way. If the mean value or variance time dependent, then non-stationary. If the mean and variance time independent, then it is stationary. So we can define stationarity and non-stationarity in terms of the moments of the distribution function if we can express the probability distribution in explicit form. But we have mentioned earlier, in the case of a time series variable, although it is random, it is not purely random. So it is difficult to express its distribution in explicit form. That is why it is highly difficult to find out whether a series is stationary or non-stationary just by looking at its first order moment and the second order moment, because the first order moment and the second order moment can be calculated if we know the probability density function or the probability mass functions involved in a series YT. But we have no clear idea about the basic form of the PDF or PMF of YT. That's why we have to search for the alternative way. What is the alternative way? We are looking at the stochastic behavior by other way, that is in terms of the autoregressive process, moving average process, autoregressive moving average process, etc. And we are concentrating mainly on the autoregressive process. In the autoregressive process, AR1, AR2, AR3, etc. So in AR1 process, we have seen if phi 1 less than 1, series is stationary. And phi 1 is equal to 1, series is non-stationary. Phi 1 is equal to 1 has a special meaning in terms of the concept of characteristic roots. When we incorporate the concept of characteristic roots, phi 1 is equal to 1 in AR1 series means the presence of unit root. Because in the case of AR1, the value of phi 1 is equal to the value of the characteristic root. And when this value is equal to 1, we can say it unit root. Therefore, phi 1 is equal to 1 means the presence of single unit root, and the presence of single unit root in AR1 means the series follows random walk model. The series following random walk model exhibits stochastic trend, and the series following random walk model can be converted into a stationary series by taking difference. That is why it is called DSP. So a non-stationary series with unit root, in other words, is called different stationary process, because a non-stationary series with unit root could be stationary after taking difference. Similarly, in another kind of non-stationarity, when there is no presence of unit root, we have another type of non-stationarity that is called non-stationarity without unit root. Non-stationarity without unit root means, in this case, the series exhibits only deterministic trend. Okay, and in this case, we can generate a stationary series by detrending it. That's why this series is called trend stationary process. Therefore, the non-stationary series without unit root is synonymous to trend stationary process. So there are two types of non-stationarity. One is TSP, another one is DSP. In the case of TSP, there is no unit root. In the case of DSP, we have unit root. In the case of TSP, we have trend in mean value only, no trend in variance. In the case of DSP, we have trend in variance with or without trend in the mean value. If the series follows random walk without drift, so in that case there is no trend in the mean value. But in this case also trend in variance. If the series YT follows random walk with drift, in this case we have both trend in mean and trend in variance. Okay, so we can summarize these two type of non-stationarity in this way, TSP versus DSP. So TSP is a non-stationary process. DSP is also a non-stationary process. In the case of TSP, we can generate stationary series just by detrending. In the case of DSP, we can generate stationary series by taking difference. In the case of TSP, we have a trend in the mean value, which is called deterministic trend. In the case of DSP, we have trend in mean value or no trend in mean value. So in the case of DSP, there may be deterministic trend or there is no deterministic trend. In the case of TSP, no trend in the variance, that is no stochastic trend. But in the case of DSP, trend in variance, that is there is a stochastic trend. In the case of TSP, the effect of shock is transitory. Why? Just look at the expression, deviation of actual y from its trend value. This yt is the actual time path of y. This is the trend value. And this difference is the epsilon t. And by assumption, epsilon t is white noise. That's why its effect will be temporary in nature. But in the case of DSP, the effect of shock is permanent. That is, it persists for longer period. Because in the case of DSP, we have unit root. In the case of DSP, we have stochastic trend. How to get stochastic trend? Stochastic trend appears by the accumulation of the previous shocks. So in the case of stochastic trend, shocks will be accumulated over time. So if shocks are accumulating over time, so there is no chance to eliminate the effect of the shock, at least for the shorter period. That's why if the non-stationarity appears because of the presence of unit root, it will be more dangerous as compared to the non-stationarity because of without unit root. Because non-stationarity without unit root, in that case probability function will be changing, but this probability function will be changing only because of the change in the mean value, and we can manage it because mean value is observable. But if the non-stationarity appears because of the unit root, so in that case we have both kind of trend, deterministic trend as well as the stochastic trend. And stochastic trend appears because of the accumulation of the shocks. So shocks, that is the effect of the shocks, has been accumulating over time. So if you put a shock one by one gradually on a system, the system will be disturbing and there will be no sign of the system to converge towards its equilibrium value if shocks persist over time. So that is the case for non-stationarity with unit root. So in the case of non-stationarity with unit root, the effect of shocks will be long lasting. But if the series is non-stationary without unit root, in that case the series may deviate from its equilibrium, but this deviation will be purely temporary. In the case of non-stationarity with unit root, in this case the deviation will be permanent. So these are the basic concepts of non-stationarity, non-stationarity with unit root, non-stationarity without unit root. Okay, have you cleared these points at least up to this?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
আমি একটু পরে তোমাকে কল ব্যাক করছি। So in the next class we will start with the unit root test. Okay, so you go through the points we have discussed today. I will send the handouts I have shown in the screen to your common mail ID. I also send the recorded version if we have to your common mail ID, so you can share it. And 879 participants in this class, but you have more than 200 in a class, so many persons cannot participate this class. So you can share the recorded version of this class to them, so hopefully it will be beneficial for them. And despite if you have some problems, if you face any problem to understand the concepts, so concentrate on only non-stationarity with unit root, non-stationarity without unit root. So go through these parts only several times, and take some more steps in your exercise books to clear those points. And after that, if you have any doubts, you can send me by mail in a Word file as you had sent earlier. And in the next day means coming Monday we will meet again for analyzing unit root test at 8 p.m. evening. Okay.
Okay, sir.
Okay. Thank you, sir. Okay, sir. Okay, sir.
Thank you, sir.
Okay, sir. Thank you, sir.
Okay, sir.
Keep safe
Yes,
yourself,
sir.
because
Thank you, sir.
it is a very, very critical time for all of us. So be careful yourself, careful for others, and keeping these constants as possible. Go through.
So, coming Monday কটার সময় একটু আরেকবার বলতে পারবেন?
Huh?
কটার সময় হবে ক্লাসটা?
8 p.m.
4th May.
সন্ধে 8টা, সামনে সোমবার সন্ধে 8টায়
Sir. Okay, sir.
ইউনিট রুট এর পরের পাঠ। তাহলে আমি স্টপ।
Okay, sir. Okay, sir.
গুড বাই।
Thank you, sir.
Thank you, sir.
Sir.
Thank you, sir.
Good night.
Thank you, sir.
Good night, sir.
Thank you, sir.